Alright guys, we're going to pick up right where we left off. So I need you to get out a couple of things. First of all, I need you to get out your notes that we were working on yesterday, 311, and then your calculator. We're going to use a calculator for this first problem. And then I need you to get out a sheet of paper. So while I'm erasing, get those things in order. And here we go. In our notes, 3.11, we are going to do problem number 7, example 7. This one will require your calculator. We want to know where the P of X where that equals 2. And we're solving from 0 to 2 pi. Okay, so we're going to solve that little equation there. So the first thing we'll do is subtract the 3. It's going to give me a negative 1 over there. Shut the door. Okay. Now we'll divide by 1.7. So the cotangent of, not x, the cotangent of that mess equals 1 divided by 1.7, which we're going to go to our calculator, so you're welcome to leave it like that. If you'd rather, you can change that. That's 1 over 17 tenths. So that's 10 17ths. It doesn't really matter. It makes no difference. We're going to go to the calculator. So here's the deal. We've got some angle out there. Right, it's called this, but let's pretend for a moment that it's just x. Let's suppose it just says this. Cotangent equals, well, 1 over 1.7, I'll just leave it like that, which means the tangent equals 1.7. Where is that angle? Now, for the time being, I'm calling it x. Where is that angle? Well, it is either in quadrant 1 or quadrant 3, because that's where the tangent is positive. I have no idea what it is, so I'm going to go to my calculator, make sure I'm in radians, and type second tangent, arc tangent, 1.7, and that angle right there, here's my circle, that angle right there is 1.039. So in the interval from 0 to 2 pi, remember, we can have an answer here, and we can also have an answer down here. So x, this is the equation I'm solving. We started out as cotangent equals 1 over 1.7, which means tangent equals 1.7. I'm just trying to figure out what this thing is. So it's either 1.039 or it's pi plus that, which makes sense because the period of the tangent's pi. So 4.10 or 181. Now here's where we have to be careful. Those are the actual angles where the tangent is 1.7. This isn't an x. This angle right here is 0.5x minus 1. So 0.5x minus 1 is 1.039, and 0.5x minus 1 is 4.181. Does that make sense to you? Remember, this simply says there's an angle out there whose tangent is 1.7. Well, we figured out using our calculator that angle is these. Well, the name of that angle is 0.5x minus 1. So now I'm going to figure out what the actual x values are. So I'll add 1 and divide by 0.5. So 2.039 divided by 0.5. So my actual x values are 4.078 and 5.181 divided by 10.362. Now we got a problem here, guys, because our domain, our x values, these are the real x's, these were the made up x's, I'll give them another. Our x values have to lie between 0 and 6.28. So this one's way too big. X can't be that. Too big. X can't be that big. So it looks like the only answer to the problem is 4.078. Now, without getting too confusing, hopefully, that makes sense, sort of, because when you put a coefficient on the x, that divides the period, right? So we are restricted to 0 to 2 pi, but all that is getting divided by a half. So it is stretching way out, and it stretched so much that this got too far out from our domain. So there's your answer. Perfect, perfect, perfect. Okay, now turn to page, or back of page 3. The back of page 3 of your notes. And we're going to go through these problems. So we're on the back of page 3 of your notes, the back of page 3. And we are going to find the exact values. We practiced this a little bit last time. Cotangent 3 pi over 4, secant 5 pi over 3, and cosecant 7 pi over 6. Okay? I'm just going to put my unit circle right here in the middle. I told you before, I like to do this in terms of the regular functions, and then I'll do the reciprocal. So the cotangent of 3 pi over 4. Well, 3 pi over 4 is here and here. X and Y match. So when I put them on top of each other, I'm going to get negative, 3 pi over 4 is over here, I don't know what I'm thinking of. Here. X and Y match, so when I put them on top of each other, I'm just going to get negative 1. So the cotangent is negative 1. It's also negative 1 down here, but that wasn't our problem. Our problem was that one, right there. 5 pi over 3. 5 pi over 3 is down here. The cosine of 5 pi over 3, cosine 5 pi over 3 is positive 1/2. The reciprocal then, the secant, would be 2. 7 pi over 6 is also over here. 7 pi over 6 is over here. The sine of 7 pi over 6 is negative 1/2. So the cosecant, the reciprocal, is negative 2. If you are struggling with that, please come to office hours so we can get it straightened out. This use of the unit circle, hugely important. And I know you're just learning the reciprocal relationships, but you gotta get those memorized. Cosecant is the reciprocal of the sine. Secant is the reciprocal of the cosine. And cotangent is the reciprocal of the tangent. You can also think of it as x over y on the unit circle. All right, number 2. When it says that f of a is 0.235, that literally means that the cosine of a is 0.235 because f is the cosine function. Your job is to find g of a, which is the secant of a. Well, kids, that's easy. If the cosine is 0.235, then the secant is 1 over 0.235. Now, we're not supposed to mix fractions and decimals, so 1 divided by 0.235, and then math frac that, and it is 200 over 47. That way we don't have to round it off, because 1 over 0.235 is some big long decimal. So remember, to change a decimal into a fraction, you just press your math button. The very first option is frac. Press enter, and you'll get your fraction. The parent function, cosecant, is stretched by a factor of 2 and shifted up 5 units. What I am not sure of, it's not very clear as to whether that is a vertical stretch or a horizontal stretch. I think they mean a vertical stretch. So we're going to insert the word vertical in there, and we're going to take our cosecant function, which is the reciprocal of the sine. So I am sketching, there's my sine. Here is my parent function. By parent function, we mean the regular cosecant function. Get the sine out of there. Okay, now we have stretched it vertically. I'm inserting the word vertically because based on the questions, I think that's what they mean. So I'm going to stretch it vertically. That means that instead of coming down to 1, it's going to be up at 2. It's doubled, factor of 2. So now its lowest point is at 2, and its highest point is of that parabola is at -2. So the range is now 2 to infinity and negative infinity to -2. That's the range when I have stretched it by a factor of 2. Okay, now I'm shifting it up 5. So now I'm going to take this whole thing, my purple picture, let me get rid of the black. I'm going to take my purple picture and move it up 5. Well, as usual, I didn't plan this very well, because if I move that up 5, it's going to go way up here. And now, that low point, up 5, is going to be at 7. And this one's going up 5, so now it's going to be at 3. So what is my range now? Everything got shifted up 5. So it's going to be 7 to infinity and negative infinity to 3. That is my range. I simply took the range I had and added 5. All right, number 4. Which of the following is equivalent to y equals cotangent? Well, I know you probably think I'm a graphaholic, but I think it's so much easier if we just keep in front of us, this is a cotangent, and I'm only doing one period. That's my cotangent, and this is my tangent. There we go. So there are the curves. Now we want to know which of the following, this is what I want to be. I want to be a cotangent. So which of these? A, if I take a tangent and tip it upside down, will it be a cotangent? No, no. A non-observant person would say yes. But what's different? The asymptotes of the tangent are in a different place. So even if I turn this upside down, it's not the same curve. The shape's the same, but it's not the same curve, so it's not A. B says, okay, turn it upside down, which you absolutely have to do. If you want that shape to match that one, you're gonna have to turn this one upside down. And shift it pi over 2 to the right. So what does that mean? That means that this point right here is now gonna be at pi over 2. So if this goes pi over 2 to the right, that point, that 0, is gonna be there. And the asymptote is gonna be at pi. And that asymptote is gonna be at 0. B is your answer. Turn it upside down, shift it to the right, pi over 2, and you can turn a tangent into a cotangent. All right, C can't possibly be right. The answer is B, but we're going to talk about the other ones. C can't possibly be right because it's not upside down, so no. D, be careful. Tangent is odd. So when you take the tangent of negative x, it is negative tan x. So actually, A and D represent the same picture. Now, they are not the right answer because we don't have the asymptotes in the same place as a cotangent. But A and D are indeed the same equation because tangent, like sine, is odd. Cosine is even, sine and tangent are odd. Okay, and finally number 5, which of the equations has no solution? Well, we're not going to actually work any of them out, but let's solve for the function. So here's what I mean. For problem A, if we subtracted 2 and divided by 5, we'd have cosine x equals 2/5, or cosecant x equals 2/5. For B, we have tan x equals negative 5/3. For C, we have secant x equals negative 4. And for D, we have cotangent x equals 0. Now, I am not solving these. To actually solve these would mean find x. What angle has a cosecant of 2/5, for example? By looking at these, though, you should be able to tell me which one isn't solvable. All these are solvable except one. We could right now answer every single one of these except one. The one we can't answer is A. And the reason A can't be answered is this means that the sine of x is 5/2. And what do we know about sines? They cannot be bigger than 1 or less than negative 1. We talked about this last time, that because the sine is bounded by negative 1 and 1, its reciprocal will be outside of that. So the cosecant has to be 1 or bigger, or negative 1 or smaller. So there's no way a cosecant can be 2/5. Impossible. So the answer is A. Perfect, perfect, perfect. Okay, one more thing. I asked you to get out a piece of paper because the next time we are together in person, we're going to have a little quizzy-poo. Going to be a small one, going to be 3 problems. Okay, here are the problems. One of them is going to be a little inequality. It isn't going to be one of the wild and wacky ones. There's time for that. We'll save that for our big quiz. But I just want to make sure you know how to solve an inequality. So here it is. Make sure I'm still in the viewing area. It would be hard for you to solve if you couldn't see it. Yep. Okay. So let's get our tangents on the same side. So we'll move the 4 tangent over, subtract 4 tangent, subtract 6. And now I want to know, where is the tangent bigger than -1? And our domain is as it has been. Okay, so a couple different ways you can do this. We discussed it before. You can use your unit circle. Where is the tangent -1? Well, the tangent would be negative here and here. And if it's 1, that means y and x are the same, so it has to be a pi/4 angle. And since we're in quadrant 2 and 4, this would be 3 pi/4 and 7 pi/4. That's where the tangent is bigger, or excuse me, equal to -1. Now, I think I told you before that I actually like to use the curves for some of these. You are welcome to do your unit circle, but remember, we're doing tangent now. So we're looking for where y and x are the same, but we want it to be bigger than -1, so we need y to be bigger than x. So I'm going to look at my tangent curve. For me, this is easier because I also have to keep in mind we've got asymptotes to contend with. So here's my tangent curve. Now it looks different. You're all thinking, wait, Ms. Ward, that doesn't look like what you graphed a minute ago. Well, what I graphed a minute ago was the standard tangent. And that's good. That's perfect, except that's my domain. So -pi/2 to pi/2 does not cover it for me. I have to go from 0 all the way out to 2 pi. So I hope you can see it there. All right, where is it -1? Well, we already figured out it's -1 right here at 3 pi/4 and right here at 7 pi/4. That's where the tangent is -1. Now, where is it bigger than -1? Well, that would be, here's -1 right here. It would be every part of the tangent curve between 0 and 2 pi that's above that line. So it would be this piece right here. It would be this piece right here, and it would be this little piece right here. Those have tangent values bigger than -1. So what have I shaded? Everything from 0 to pi/2. Pi/2 has to be open because it's an asymptote. It can't be included ever in any conversation. Or 3 pi/4 to 3 pi/2. Or 7 pi/4 to 2 pi. And because of these directions, 2 pi can't be included. The the 3 pi/4 and 7 pi/4 are not included because of that. There's no or equal to on that. 0 can be included. It's included in the domain and it's part of the shaded. And of course the asymptotes are not included. Okay, there's one problem. All right, and then you're going to have a quadratic to solve. It's going to be an equation though, not an inequality. Your inequality is going to look like that. Your equation is going to look like this, same directions. little quadratic, we're gonna solve. So what do you think we ought to do? Oh my gosh, I hope you know. It's a quadratic. We have to get it set equal to 0. So 2 sine squared minus 3 sine plus 1. Once you get it set equal to 0, then you're going to solve it like you solve any quadratic. If it factors, go ahead and factor it. If it doesn't factor, then you can use the quadratic formula. You can use that anyway, but I think it's harder than factoring. I think this one factors. If I read it right, it does. I'm going to have 2 sine and sine, and minus 1 and minus 1. Does that give me what I want? I think it does. So get your equation set equal to 0, factor it. This says that the sine equals 1/2. This says that the sine equals 1. Where does the sine equal 1/2? Well, the sine equals 1/2, either here or here. And the angle is, for a sine of 1/2, pi over 6. So over here, it is pi over 6. Over here, it would be 5 pi over 6. So the answers to that part are pi over 6 and 5 pi over 6. Where does the sine equal 1? Notice, I'm not doing any shading. This is an equation. I just want to know, where does it equal? Where does the sine equal 1? Well, think about your circle. Doesn't the sine equal 1 when y equals 1? So that would be pi over 2. And there are the answers to your question. Perfect. Okay? Now you're going to have a calculator problem to solve. Okay, so here we go. Directions are the same, 0 to 2 pi. You're looking at this thinking, I need a calculator for that? Yeah, because look, when you start solving, you get 5 cosine squared equal to 4. And then cosine squared equals 4/5. And when you square root both sides, you do not get root 3 over 2. Or root 2 over 2, or 1/2. You don't get any of those things. So we're going to need our calculator to solve it. Now we are going to square root both sides. So cosine equals plus or minus the square root of 4/5, which if you prefer, you can write as the square root of 0.8. Or you can just leave it like that. I wouldn't worry about trying to simplify that. It's not going to matter. We're going straight to the calculator. Where does the cosine equal that number? Well, since it's plus or minus, won't it equal it in every quadrant? So I'm going to go to my calculator and find the angle whose cosine is the square root of 4/5. So second cosine, arc cosine, square root 4 divided by 5. And that angle is, this one right here, is 0.46, I'll just say 36, I'll take it out to the 10,000, 0.4636. Okay? Now, think about that for a second. You are finding, that's this one right here. You also need to find the one that comes all the way around to here. That's the next one over here in quadrant 2. Well, keep in mind, if that's 0.4636, so is this. So how will we find that purple dot? Pi minus 0.4636. 2.6779. Okay, now I need this one down here. I'll do this one. This is going to be pink. This pink dot right here. So now I need to go all the way around to that pink dot. Well, keep in mind, isn't this little angle right here also 0.4636? So that means pi plus 0.4636. .6052. And then finally, this blue dot clear over here in quadrant 4. Remember, when we did plus or minus, we're going to get an answer in every quadrant. 2 positives, 2 negatives. So I need to come all the way around to here. Start there. Come all the way around to here. Keep in mind that this angle is also 4636. So that blue angle is the entire circle except that much of it. So 2 pi minus 0.4636. 2 pi minus 0.4636. 5.8196. Using your unit circle, you're very comfortable saying, okay, this one's pi over 3 and this one's 2 pi over 3. But that 2 pi over 3 came from pi minus pi over 3. That's how you get those numbers. You're just comfortable with those. Here you're doing exactly the same thing using these decimal values. So the answers to the question are that black one, this black one, that which is purple, and then the pink and the blue. Okay, so that is going to be our small quiz that we will take next time we are together, and then we will pick up and continue working. Hope you're having a great day and hope the SAT went well.